So, just want to start off today by expressing a bit of disappointment with yesterday. The class kick doesn't have to be done during the class time, but it's really good if you get it done on the day. And had some pretty low numbers of people giving it a go. I know this topic's hard. This is the last part of this topic, and then we're moving on. If you can stick it out to the end, do your best, the end of term, have your 2 weeks of break, and then we'll have a better topic next term, next week even. Just, you got to stay on top of it, or it's going to catch up. So if you need a hand, hop on the class Zoom during class time, and I'll be there to help you out. So today as well is more practical, which is nice because we do like our financial maths, and this is going to help us analyze some things financially, and all the examples are going to be about finance. So break-even analysis is all about how many things do I need to sell, or how many subscriptions do I need to provide until I don't make any losses on this project anymore. So for instance, you might buy a shop and then start producing some goods in that shop, and the question might be, how many products do I need to sell to outweigh the fact that I bought the shop to begin with? A bit more simple, you might buy coffee at a cafe, and then it costs you, say, $3.50 each time. Your other option might be to buy some $15 bag of coffee and make your own coffee at home. How much coffee do you need to make at home until you've made your money back? And then from there, you're just making money. And it's going to look like two lines that intersect, just like we've been looking at this topic with linear equations. And if we can graph our lines, look at where they intersect, that is where we start making our money back. A few key terms. So break-even point is where income equals initial costs. Now, income. So income equals, textbook uses MX. I'm inclined to use MN, so number of things we sell. But just to keep it like the formula that we know, MX plus C. So the income equals MX. So M is the gradient, and remember that always means Y per X. So dollars per number we sell in this case. So if you make $6 per toy that you're selling, it'll be $6 times the number of toys. Or sorry, if you sell the toy for $6, you're not making 6 per toy, but you're selling it for 6, then it'll be 6 times the number of toys. Alright, profit. No, let's do costs first, actually. Costs. So, initially, like in the coffee example, you might have bought the coffee for some amount. That's your starting value, remember? Always plus C. And then it's still costing us money per coffee that we're making, because we're still providing the milk, and we're still boiling the jug, and all of those are still costs. So we've got cost per item plus the starting amount. And what we want is we want to make a profit. And we work out our profit by saying, well, how much income do I have? And how much do I spend to get there? And the difference is going to be how much money we made, or if that's a negative value, it's going to be how much money we lost. On a graph, what that looks like is this. Let's say we've got our income, which I'm going to do in red. We start off with no income, and every time we sell something, we get a bit more income. Now, costs, they're going to start higher because there's usually some startup cost involved. But I'm going to draw a line quickly. So it's straight. Hopefully the gradient isn't as high because we aren't spending as much per item as we're making per item. Now there's 3 key features on this map, and I'm going to use, let's use galaxy color, why not? So in here, this is loss. So I should label my axes as well. This is dollars, and this is number of items sold or produced or something like that. So in here is our loss section. Our costs are currently higher than our income. Then here we've got our break even point. That is where we've finally made our money back. So we still haven't produced anything. Why is the rub out button not working? There we go. We still haven't actually made any money, and we have spent a bit of time making items, but at least we're not losing any money. And then let's go rainbow for profits. So in this section is our profit. So our costs, our blue line, are now lower than our income, so we get to keep all that extra money. This is what it's going to look like when you're doing a question. You're going to have plot the loss, plot the costs and plot the income, and you're going to see the difference. Let's do a question. So, let's do the coffee example. Like a cafe. So, a cafe buys coffee, beans, for $100. It costs 20 cents. Actually, let's say $1, because we're going to include employee wage costs in this as well. It costs $1 for each coffee they make. In other costs, and let's say each cup is sold for $4. How many coffees? Do they sell, or do they need to sell to break even? Now, a lot of these questions, if not all of them, let me just quickly check. The level 3 questions don't. But they either give you the graph or they give you the equation. So I'm going to go through how to find the equation, but you only need to do that in the level 3 questions. So they bought beans. Let's do costs first. So costs, they bought beans for 100. So our initial value, our C, is 100, and it costs $1 for each coffee, so 1x. We often don't need to write the 1, but it's a good reminder of what the gradient is, that there is actually a value there, so I'm going to do it. The income. Well, there's no initial income. They don't get any money to start, but each cup is sold for $4, so 4 times x, the number of coffees. Now we're going to plot that. I'm just going to quickly grab a blank graph, because why not? Make it neat, hey? Blank graph images, grab Old Faithful, we've used this one a few times now. your new tab. Alrighty. So over here, we've got our dollar amount. Down here, we've got number of coffees. So let's go up by, let's say 5s for coffees. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. And dollars, well, I'm going to need to get to at least 100. Probably even 200. 1, 2, 3, 4, 5, 6, 7. Let's go up by 40s, because why not? 40, 80, 100, no, 120. 160, 200, 240, 280. Alright, now let's plot costs first. I might write income in blue, just so we've got our two different colours for the two different graphs. C equals 1x plus 100. Remember, M is gradient, C is initial value. So we come up to 100 as our initial value on the line, because that's where the 0 is, that's initial. Then I need to come along and find the gradient. So for every one I go across, I go up 1. But these grids aren't in line. That goes up 40, that only goes across 5. So let's say I go up from 100 to 20. I'm going to also have to go across 20. So I've gone across 20, up 20 to get my second point. Now I'll get my fancy ruler out here. Which is here. There we go. I think that should have been in section, so it's pretty close. Alright, income. 4 for every coffee. So for every one grid I go across, which is 5, I need to go up 4 times that. So every one I go across, I need to go up to 20. Because 5 across, 20 up. And that starts at 0, 0, because there is no C value. Alrighty. So this line should look something a bit below, but that's alright. It'll work. Now, we can quite clearly see here that they intersected nicely at 35 coffees. So there we go, that's our answer. How many coffees do they need to sell? 35 coffees. Now, that might not be exact, but we are graphing, so that's fine. I think the real answer might have actually been 34, but it's a good idea to check it algebraically at the end. 1 times 35 plus 100 is 135. 35 times 4, that's what? 90, 120 plus 20, 140. Yeah, so I think the real answer would have been 34 coffees, but we don't have that kind of visibility on this graph because we're not using as good a scale. But algebraically that works. 35 coffees, we have a higher income than we do an expenditure. Alright, so that's how we do it. I'm going to give you the class kick and the exercises. As this is the last exercise, I'm going to send 2 class kicks today. One of them is going to be to collect all the work, and one of them is going to be doing some worked examples. So I'm going to make all the work due next Monday, so you can be working on that, and getting it submitted. I know a couple of us have already finished and got it ready, so you'll just need to finish off 5F today and submit that. Others might need to do some catching up over the weekend. But good luck with the work, and make sure to come onto the class soon if you've got any questions.